Okay, so I'm a little pressed for time here. I got a half an hour and I got some things on the board. And I really want to do a little rapid fire 3 in this case. When you get calculations later in the semester that you struggle with, I'll do 5 in a row. But right now it's just getting a whole bunch of discussions in front of us, and I want that process to continue for a while until I feel like I pushed you enough. Okay, and I'm not sure when that'll be, but I generally can tell. All right, so I'm just going to do rapid fire 3 on a bunch of the problems that we've been working on already. And your job is to stop the video once I put the problem on the board, and you try it yourself. And I am going to talk fast, but you can always replay it and look at the, stop it and see what number goes where and what number, that kind of thing. All right, so here we go. Let me move this desk a little closer. And I think I got everything. Yeah, all right. So we haven't talked about this yet, but this is a graph, 2x minus 5y equals 20. 2x is a product. And we always want products to equal 0 because that tells us the critical numbers, the easy numbers to work with. And so we're going to put a 0 in for x. And so if I put a 0 in for x, it's like putting your hand over it, and then you're just solving that equation. And minus 5 into 20 is -4. So we go here, 0 horizontal. I'm not moving in the positive direction. I'm not moving in the negative. I'm staying right here, but I'm going down 4 units. So we locate 0, -4. That's the y-intercept. And this is a product. Maybe you can guess what I want that product to equal. Yes, you're right, 0. So that's like covering your hand over it. And therefore, 2 times 10 is 20. So therefore, if I cover the y, I'm letting the value be 0. So there's no numerics here at the moment. And that's 10, and that's the x-intercept. So this is called standard form. So we draw the line, we get a couple of arrows showing that it's going in the positive direction to infinity. The y values are getting bigger and bigger at a constant rate, and moving to negative infinity on the left. And that's how you graph those. Okay, standard form. We get an eraser. All you got to do is follow. Can you graph the next one on your own? And that's why it's a rapid fire 3. All right, so what's the next one? The next one, oh, 4x. Why don't I put my hand over it? And it looks like I got the y-intercept. Looks like it's 8. Oh, get that cap here so I don't lose it. All right, so 0, 8. Let's call that 0, 8. Now I have something that's 8 units, and I'll look at the x-intercept, which is 6. 4 times 6 is 24, providing y is 0. And so 0 is no altitude for y. And I'm looking at 6. So if that's 8, 6 is a little shorter. So 0, 6. So there's that. I'm sorry I said this the wrong way. A little dyslexic. I told you I had a half an hour. So hopefully you didn't stop it just then. So y is 0. I meant to put that there. And then horizontal is 6. All right. That should have been maybe back here a little bit as a more accurate graph. So this function is always decreasing. You always put your finger on a graph and move to the right. So all these numbers are going down. 7x minus 2y equals 23. Do that one right here. All right, so you're pausing the video, you're trying to get it. I'm going to look at the x and y intercepts. The x-intercept is 23/7, which is near 4. So 23 over 7 gets me no altitude, right? Altitudes are positive and negative. Positive above the x-axis, negative below. Now let's get the y-intercept. So minus 23 over 2, which is near negative 12-ish. So that's 4, 12. It's further down here. It's probably down here. But that's all it takes is 2 points to graph a line. And so when I ask you a test question and I ask you to graph that, I expect to see the x and y intercepts, or you don't understand what standard form is. Okay, so there's no reason to convert it into slope intercept, even though you were drilled to write slope intercept in algebra 1. We don't work with it all that much in the higher levels. All right, so now rapid fire 3, write the equation of a line. So we have -5, 7. I think it's nice to write it that way, -5, 7, and 8, 3. So you pause the video, you try it. And what I see here is a change of 13. You've got a positive 13. x's, right? The x's change by 13 and the y's go down 4. From 7 to 3 is down 4. So the change in y over the change in x is minus 4/13. And I want to use negative 5, 7 as my building block. And so negative 5, I'll say x plus 5. So when I drop negative 5 in, I get 0. 0 times anything is 0, but I want 7. I got the marker. There you go. There's the calculation you're looking for. Okay, so that takes care of this one. So pause the video. 1429, 1950. 1429, 1950. Again, for our purposes, I think seeing it as 1429 and 1950. Okay, so we're going to work with 1429. Come over here and go x minus 14 plus 29. And then we're looking at the change in x, which we're going to get rid of the change that doesn't work, and we're going to bring in the change that does work. What's the change from 29 to 50? I got to go up 21. That's what I want. I want 21 plus 29 to get here. Now, what do I get when I put my second x in? So my second x is the number 19, and 19 minus 14 is 5, and we can see that from 14 to 19 goes up 5. That's the quicker way to get it. And so there's that function. Okay. Now, negative 7, negative 1 to 920. Let's take a look at this one. All right. Can we do it from here? Negative 7 to 9. That looks like it's going up 16, and that's the change in x. Negative 1 to 20. Oh, there's 21 again. So there's the rate of change. And I'll elaborate on that during the lecture part of this video. What do we want to build it off of? Let me get rid of the things that get in the way of seeing what we want to build it. We want to build it off of negative 7, negative 1. So negative 7 is going to turn into negative 1. So I got to get rid of negative 7. So when I put negative 7 in here, adding 7 gets rid of it. And then I can simply write negative 1. So there's some quick practice on linear equations. And I hope I can get this in under half an hour. All right, so what did I ask here? All right, so name 3 points. Name 3 points on the line x minus 4 plus 7. Now, let's get 5 points. Let's get 5 points. Well, what do you see? I see this, which tells me I know what I'm starting with. Looks like a 4 gets a 7, because that's why I'd write that. And do you understand what that number is? Where that number comes from? And if you said 9, you'd be right, because my x's are changing by 5. In fact, I could even go from 9 to 14. I could go from 14 to 19. Those are all jumping by 5. And it looks like my y's are going down 3. So 19, negative 2 should be on here. Let's see if it really is. Let's put 19 in here. And see if I can write this side as the number negative 2. Well, 19 minus 4 is 15. And I don't know if you know this or not, but 15 is a multiple of 5. In fact, it goes 3 times. It goes 3 times. So my y values are going to go down 3 times. Down once, down twice. Bingo! Down 3 times. Yes. And that's negative 9 plus 7. Oh my goodness, it is negative 2. I guess I can trust this. All right, so now we try the next one, and you're pausing the video. And we're going to do some other rapid fire, depending upon me keeping track of the time. Oh, we're good, we're good. So y minus 2 equals 2/3 x plus 5. Oh, I don't know why I wrote that, sorry. Oh, geez. You're pausing the video, but maybe I should do it off of, Start again. My apologies, you might have done it right in the lab and moved this and put it with that, but I'm not trying to trick you here. I just put this up too quickly. I did it again here too, didn't I? Okay, so let's get rid of that. I don't know, I was doing a rush job here. All right, so let's start with this and see if you can name 3 points on the line. Okay, what I was anticipating is, and I'll pause the video now. I'm gonna make sure you can see all this. Thank God you can. All right, I do think you should move, although this is called point slope. And you should have studied that in Algebra 1. Point slope, all right? I like to move this y value over here. Subtraction of 2 becomes addition of 2, especially when you're first learning how to work with this. All right, so what's the first x? This is a product, yes? Remember we talked about products over in the first problem? You want to make a product equal 0. This is not part of the product. So that's the product. What makes that product equal 0? -5. Right? And 0 times anything is 0. We'll talk about that on day 1. So if you put -5, you get a 0 here, which means you get 2. And now it's all about those numbers reflecting change. So let's say you work 3 hours. You work 3 hours. You work 3 hours. What happens? You make $2. You make $2. That's what conversion is all about. And that's a constant rate of change. We're going to talk about that in a moment when the lecture starts. All right, so there's some quick linear work. Did I have other linear work? While we're at it, let's say we solve some equations quickly. Let's do 2/3 x minus 4 plus 7. No, what we got to do is put that in slope-intercept form first. We got to do a few of these. So you pause the video, see if you can put that in slope-intercept form, and I'll do 3 of these in a row. And hopefully you'll put something in your pocket, maybe one of these problems in your pocket, because it's going to be on every test the rest of the semester. All right, so let's do the multiplication. 2/3 times x is 2x over 3. Right? I really wouldn't, so I'm multiplying x by 2 and dividing by 3, and it's nicer, I think, if you write it as 2/3 x. That's fine. But now we got 2 times -4, which is a negative number, positive times a negative, and 2 times 4 is 8. And then I got to divide it by 3. All right, now I got to add 7. So what does that become? 2/3 x minus 8/3 plus 21 over 3. And I think you can see where that number comes from, I hope. Now I have something that is, like terms. The divisions are alike, so I can put the -8 and the 21 together. And that gets us positive 13 over 3. All right, so if I was graphing that, this is a product. You want products to equal 0. So we would put 0 in for x. So I'm not moving the positive or negative horizontally. 0 for x gets me 13 over 3, 4 1/3. So that gets me 0 and 13/3, gets me my y-intercept, because this is slope-intercept form. And I'm going over 3 units and up 2, maybe that's 2, to a new location. If you wanted to know what that location was, you'd have to add 3 to this. And that would be 9/3. I'm sorry, that would be 3. And this one would be adding 2/3, so 6/3 to that. But I won't be giving you fractional work for a while. Okay, so that's just how you would graph that. All right, so to give you another one, you try it. All right, let's do -5/7 x plus 2 minus plus 4. All right, so -5/7 x. I mean, it doesn't matter what the number is, you're multiplying it by this. -5 times 2 is -10 over 7. And 4 is how many 7s? Can you write that 7s right here, right now? I hope you can. 28 7s. So what's the slope-intercept form? -5/7 x plus 18 7s, which is a little smaller than 3 units. So we're a little bit smaller than 3 units going up. Going down 5 units and over 7 puts me here. Decreasing function, which we knew to begin with because it's a negative multiplier. All right. 3 more quick questions here. 1 more quick question. 3 points. No, we're not doing 3 points. So y equals, how about we do 7/6 x plus 4 minus 5. All right, pause the video, you do it. So you should get 7/6x plus 28 over 4. And 28 over 4, you might want to, well, that's just 7, so I didn't want to do that. All right, and 7 minus 5 is just 2. All right, so did I want to do that? No, I didn't. 20, it was over 6. I was going to say, it didn't seem right. So 28 over 6, probably should reduce it. Okay, so 28 over 6 is 14 over 3. I tell you, divide both by 2. So we got really 14 over 3 minus 5, which is 15 over 3. And it looks like we got 76x minus 1/3. Okay, so down 1/3, let's call that a third. Up 7 units over 6, a ratio of 7 to 6 is almost 1 to 1. So this is a certain length. I want to go just a little bit smaller. And there's your line. Okay, so what's next? What's next is a little lecture. Want to put some thoughts in your head, all right? Which I don't expect you to be able to necessarily. What do I want to say here? You know, the things I'm talking about take time to learn. And the reason I'm jamming them down your throat right now is I want to have as much time as possible to talk about them every day, just a little bit. And what the hope is that over time, because we're doing it every day, it becomes working knowledge. All right, to give you an example of a different way to learn, we'll start word of the day, abstruse. This will be good because this way I can ask everybody to tell me what it means. And that tells me if you watch the video. All right, so I'll probably put a little piece of paper on every desk and go, give me the definition of abstruse. Okay, you can look it up, but an abstruse concept in math is maybe a difficult one. It's difficult to understand some of these things conceptually. Right? Conceptual understanding sometimes takes a long time for the, oh, that's what's going on. Right? And I think we can get there if we just do, you know, a little bit every day. So that's our first word of the day, abstruse. Now we're going to have a little geometric discussion. So I've already got this stuff on the board, which is good. All right, so I'm just going to talk about lines. And lines are a shape. You know, here's a line. Let's say every second I go that amount, right? So every second I go that amount. So 1, 1,000, 2, 1,000, 3, 1,000, 4, 1,000, 5. But now stop at 5. 5 units of measurement. I know, it's 5. You know, we're on some other planet. Inches don't seem to work. Centimeters don't seem to work. But anyway, that was 5 units of length. So I just made a time, which was seconds. Time was measured in seconds. And we're looking at the length of the line created. And I just said that in 5 seconds, we went 5 units of measurement. So that's kind of a 1-to-1 ratio there. All right, so how would this line get bigger? Well, I have to slow motion and add little units of change, And if you'll notice, there's a circle, there's a circle, there's a circle. That's getting larger. Right? And actually, it's getting larger at a constant rate. Remember, every second, I went a unit. 1 unit, 1 second, 1. 2 seconds, 2. 3 seconds, 3. So the rate of change is constant. So if you'll notice, as I move, that's a constant rate. Okay, so 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. And we have the equation of y equals x, the identity function, 6, 6, 7, 7. It's identical, my x's and my y's. And this is kind of run, rise, run, rise, run, rise, run, rise. That ratio is the same. So this might be 1-to-1. This might be 5 units of change, 5 units of change, but it's still 5 over 5. It's the same as 1/1. So that's a constant rate of change. Not all functions have constant rate of change. Here's a function that doesn't change constantly. All right, so what am I drawing on the boards? I think I got some shapes on the board. What kind of shapes do I have on the board? Sure look like I have squares. All right, so what's the relationship here? Well, what's -3? -3, get black marker here. -3 is a length. And what is 9? 9 is an area. Okay, so how did I get that area? I did -3 times -3. Is there an easier way of writing -3 times -3? Yeah, I could have done -3 and squared it. That's a simpler way of writing that. Simpler means less time, more efficiency. All right, so let's plot some of these places. So let's call this, I'm going to get -3 out here, and then +3 out here, right? And I'm going to say -3 gets me 9 units. I'm going to make this 9 units. So there's -3, 9. -2, -1, 1, 2. Not too bad. 4 units. I think that would be about here. 1 unit would be about here. 0 would be here. 1 unit here. 4 units here. 9 units. Oh, I missed that one badly. 4 units here. 9 units this height. I'm spreading it out quite a bit, but if I connect the dots, and I got area, right? And our biggest area is 9, just to locate that one. That's not really there, okay? I hope you see 0, 0. So some terms in math I can mention now. 9 to 4 to 1 to 0, I'll write a 0 there. That seems to be the most important coordinate. In fact, it creates a minimum area of 0. I don't think you can get smaller than that. If you can, let me know. We'll change the textbooks. So this is the vertex. And what's the function? We don't work with L and A. We work with X and Y. And where did I get my Y values from? I hope you say squaring the numbers. X is the length. And if you square it, you get the area. That's what the graph looks like. So anytime you get a graph that is in the form of ax squared plus bx plus c, depending upon the a value, you either get a cup shape up, but if I put a negative for a, then it changes a minimum to a maximum. Okay, and this function is decreasing and then increasing. I hope you can see that over here. Yeah, you can still see it, right? It's 9, 4, 1, 0, 9, 4, 1, 0, decreasing y values and then increasing y values. And it's got some symmetry right down the middle. And it looks like that's the most important value. But I was only considering this term really right now. All right, so we see x squared, right? What does a times x squared mean? Well, let me come back here. Throwing some thoughts your way. Yeah, what happened if I multiplied everything on this? When I say everything, I'm talking about the area. What if I double the area 2 times? Right? What happens if over here that I do 2 times x squared? Remember, you do the square before you do the multiplication. So there's the square. What if I double it? Well, then this distance is now twice. And this distance is twice. And we start to get a narrower, in this case, a narrower parabola. Okay? But there's more terms over here than just that. There's more terms here. There's linear term and a constant. Well, let's just start with what happens when I add a line to this. Well, we get functions that maybe I want to know what the graph of x squared plus 2x is. What if I, here's the green graph, we'll call the green graph 2x. All right, what happens when I add this graph to this graph? Well, I'm really adding the y values. Remember over there, we doubled the y values. Now I've got 2 y values. If I'm adding that y and that y, then I'm really adding this distance and this distance for that x. And so that's getting on top of this, right? And so my graph goes through there. What about on this side? Well, this is negative. And this is, well, that's pretty close to 0. I mean, it should be just a little bit above, but this very small positive. So it should go through right there. Now, we know that this graph is going to be a cup shape up. So the question is, when does it change? Well, it changes when this positive slope, that's a positive slope, is negated by the rate of change in the other direction here. That's where we get a vertex. Okay. Now, most folks in most classes wouldn't even have this discussion, right? And I'm sure that just probably threw you. But it won't be the last time I talk about it. I'm just planting a seed. But what you should have had from Algebra 1, and I don't think you have it in your pocket, and you need it in your pocket to go forward, solving equations like this. Okay, solving equations like this. And how do you do it? Well, the first rule of solving any equation is get your variables together. So I got to get 2x over here, and that's addition of 2x, so I got to get subtraction of 2x, which means it's equal to 0 now. Okay, and I don't know how to, there's a bunch of ways to solve this, but the easiest way, I don't know a bunch, but there's a couple that jump off the page at me. Get that marker out of my hand. There, now we're chipping the gas. All right, so how do you solve an equation like this? The easiest way to solve this equation when it's written in this form is something I said at the beginning of class. Write it as a product. Right now it's a difference. I'm subtracting two terms. But the first rule of writing products, and that's a skill in Algebra 1. And I know there's another way to say how to write addition and subtractions as products. Let's see, you did it for a lot in Algebra 1. Can you remember what it's called? Well, if you don't remember what it's called, maybe you didn't make this connection. It's called factoring. That's what factoring is. It's rewriting addition and subtraction as multiplication. And the first rule of factoring is take out what's common, which is x. They have a common number, right? It's kind of like saying write 8 minus 4 as a product. Well, there's a number that fits into 8 and 4, and we usually look for the biggest one, and the biggest one that fits in both is 4. 4 times what is 8? 2. 4 times what is negative 4? Minus 1. Okay, that's a product. All right, now if I divide this by 2 minus 1, I get the number 4. If I divide 8 minus 4 by 2 minus 1, well, that might throw you. Of course, you could always, say 4 divided by 1. But as it's written right now, if I write that as a product, 4 times 2 minus 1, well, then we can see, right, when we get more difficult addition and subtraction problems, that we might be able to simplify some divisions with that skill. All right, but we're just creating this now. X minus 2 equals 0. Okay, so we said products. This is a product. What makes this product equal 0? Well, whatever makes that parentheses equal 0. That's a 2. That means 2 times 2 minus 2 equals 0, which is true. Now, what did that 2 represent? You can still see this. Point of intersection. The parabola and the line intersect at 2. And 2 squared is 4, and 2 times 2 is 4. So 2 gets you 4 on the parabola and the line. All right, so if I add them both together, when x is 2, this function, right, x squared plus 2x is what we're eventually going to graph. X squared plus 2x, I hope you can see that when I put a 2 in, I get an 8 out. Talking more about this than I wanted to, so I'm trying to get to something a little simpler for you. All right, so let's look at this. And the other number that works is 0, because if I put a 0 in, 0 times anything is 0. We talked about that on day 1. All right, so this function over here, x squared plus 2x, I'll put it here now, so I don't have to move the calculator, is a graph where x is side length and y is area for our purposes right now. And we just found out by changing it to x times x minus 2, we can get a 0, which means that this goes through 0 and it goes through 2. X squared plus 2x. Okay. And we also know that the shape is cup shaped. All right. So this x is 0 and this x is 2. Can you tell me what that x is? Hope you said 1. And if I put 1 in here, 1 squared is 1 plus 2 is 3. Why the heck did I do this? I got a mistake. So excuse me while I think about talking too fast. I changed things up. If I bring 2x to the other side, this should be a negative. So the video is changing right now. We're going to go there, right? Because I want it to match up with what we said over here. So that was a really dumb thing I just did. So this as a product doesn't hurt to do it again. Is x times x minus 2 equals 0. So therefore we have positive talking way too fast here. So I brought myself back to the same thing. So this is what I was planning on writing, and I didn't want that. I wanted this. All right, and when I bring it over, it's negative. So this is where I've got to start. So excuse me. So x squared plus 2x, a little dyslexia there. That's what I've been talking about when I talked about this is 2x, this is x squared, and the vertex goes here. Okay, back to correct stuff now. So if I write this as a product, I've got x times x plus 2, and that equals 0 at negative 2 and at 0. Okay, so that's what your graph looked like, and that's what we were talking about over here. So this over here is 2, 8. All right, when we add up the y values, next is 2, then it's 4, and this is 4. If you add them up, you get 8. Now the question is, what's that? Well, that's negative 1, right? And negative 1, when I put it in, I get negative 1 times negative 1 plus 2, which happens to be negative 1 times 1, which is negative 1. And that's where that vertex is. Okay. Now, there's a much easier way to graph all of this stuff. That's the rule in the class. The rule in the class is what's the easiest way to deal with something? And it turns out that this number right here can be found by doing minus b over 2a. Now, how do I show you that quickly? And then I'll stop the video here. No more rapid fire. Because that's really what I want you to start hearing every day. That x equals minus b over 2a is the x value of a vertex. That's going to be very useful to us soon. Right, now, why is that true? Well, let's go back to the equation y equals ax squared plus bx. How do we write that as a product? Well, we take out what's common. X times ax plus b. Okay. Now, I don't know if a is positive or negative, so it could be on either side here, but what makes that 0? Because it's a product. Well, certainly 0 does, right? So 0 is always going to be in this form, one of the x-intercepts. And now we have to solve that, ax plus b, for x. Well, how do we do that? We move b over to the other side, subtraction, and then we divide by a. So it doesn't matter whether I put it here or here. I'll put it on this side. It'll be easier for you to see it over here, I think. All right, so we know we got a cup shape up if it's on this side. And then the question is, what's that x? Well, it's right in between negative b over a and 0. Now, if this was a score, let's say you had a score on a test. You got an 80 and a 60. What do you immediately know? Yeah, your average is a 70. Why? Because you added 60 plus 80 and you divided by 2. So let's add these up and divide by 2. Minus b over a plus 0 divided by 2. Well, guess what that becomes? Dividing by 2 is the same as multiplying by a half. Right? And if I multiply this by a half, there's my minus b over 2a. Okay, and I'm really overloading you right now. And I'm just having you, just hear some things right now. All right, we're going to work with that the rest of the semester every day a little bit. Every day. So I'll do I'll put one quick function in graphing form, and then we'll rapid fire 3 it the next homework, because it's really a really important calculation. I'm sorry to say you should have already done this in Algebra 1, but you'll pick it up now. All right, so let's give you a quadratic. Y equals 2x squared plus 12x minus 5. All right, so I know that this thing is cup shape up because that's positive. I also know what happens if I put a 0 in for x. A 0 in for x gets me 0, 0, minus 5. So I know 0 minus 5 is on this graph. I know what side it's on. You don't. I'm not going to go over that right now. But I just have to find the vertex. Because if I can find the vertex, then I can put 0, -5 on the correct side. It's going to be over here, by the way, because I'm on the increasing side. So this is where it's going to be, but you wouldn't know that yet. So how do I find this? Okay, we just talked about how to find it, really, the first part. Find the x. Find the x that goes with it. Oh yeah, minus b over 2a. Well, b is 12, so that's minus 12. And a, I got 3 minutes to get out of here, is 2 times a, and a is the number 2. That's a. So this is minus b over 2a. Well, that's not bad. Minus 12 divided by 4 is -3. Oh yeah, 0 is bigger than -3. It's to the horizontal to the right. Now all I got to do is find that y value. What's that y value? Let's put -3 in because we have an equation that finds y values if I know the x value. -3 squared is 9 times 2 is 18. I know the next number is that, but let's do it anyway. -3 times 12 is -36 minus 5. When you put the first two together, you get -18 minus 5, and that's -23. Okay, so remember, last thing I'm going to do, and then I got to get out of here, is I am going to write this in graphing form now because I can do it right here. I know the a term is 2 because I've got to get 2x squared. I know -3 is the vertex, so I'm going to write +3. And I know -23 is what I get when I put -3 in. I'm going to expand that right now, and you watch it come back to this. 2, that's x squared. I've got 3x happening twice. I got to do this quicker than I would want to. 3 squared is 9 times 2 is 18, but I'm just going to write 9 first. That's what you get when you square that, and then you subtract 23, right? And so I've got 2 times x squared, yes, 2x squared. I've got 2 times 6x, yes, 12x, and 2 times 9 is 18, and 18 minus 23 is -5. And I did that much too fast for you to digest that. I don't care. We're going to talk about it the rest of the semester. Bye. I got to get to a meeting.